It's the world of quadratic inequalities. And we start here by graphing an inequality, and while a little bit later we'll use our TI calculator, which will do a lot of the work for us. I graphed this over in GeoGebra just simply because I wanted to do it that way, because I want to illustrate using the test point to determine the inequality. And we've used that before with linear inequalities and linear optimization and things of that nature. So we should be fairly accustomed to that. But we see here that we've got an inequality. Y is less than x squared plus 2x plus 4. Now, I actually graphed this as an equality, and I did that for the purpose of using the test point. Because if I had graphed this as an inequality as it read, it would have shaded it for me. And we're trying to, and so we've got two regions here. We've got a region that's lying outside the parabola, and we've got a region lying inside the parabola. And we've got to determine which boundary, or which region, I should say, is going to be shaded, and which would indicate a solution to our inequality. Now, I want to use a test point, and whenever possible, I want to use 0, 0, the origin, as my test point. And if I substitute in 0 for y and solve this, I want to see at that test point, does this give me a true solution? And if it does, I shade towards the origin. If it doesn't, I'd shade the region that's going away from the origin. So let's see. 0 is less than 0 squared plus 2 times 0 plus 4. And so this really ends up at 0 is less than or equal to 4. And I ask myself, is that true? Well, of course that's true. 0 is less than 4. And so I'm going to shade the region in which the origin lies. And so, if you will, my solution set is that region. And I might look at that as it's lying outside of the parabola. Now let's look at another one. I did it the same way. I graphed it in GeoGebra. I graphed it as an equality. And by the way, if it's just a less than or greater than, it should be a dashed line, not a solid line. But again, I graphed this as an equality so that we could illustrate using the test point. And so obviously I've got a region that's lying to the outside of the parabola. I've got a region lying to the inside. Again, I'm going to use 0, 0 as my test point. And so I'm asking myself the question, if I substitute 0 for y and 0 for x, will that give me a true statement? And if it is, I graph for the region in which the test point lies, and if not, I graph away from that. So let's see, 0 less than negative 2 times 0 squared, well, that's just 0, plus 3 times 0, well, that's 0, and now I've got 0 is less than 5, which is a true statement, but this time my test point lies inside my parabola, and so my solution set, I'm going to shade that region that indicates my solution set. Now, next up, we'll use the calculator, and we'll actually use it not only to do the shading, but we're going to also solve the quadratic inequality. I know you can't wait, neither can I.